Hello everyone and welcome to this lecture. In this lecture we will deal with the branch control instructions of 8086 microprocessor. So let's see what branch control instructions are. Normally in case of branch control instructions, what happens then, these are the instructions which we use if we want to move from the sequential manner of the program to some other part. That means suppose we have jump instruction in case of branch instruction. So that what does that means? You don't have to execute the program sequentially. That means you don't have to move to every line. In case of branch control instructions, we can use those particular instructions just to move from one particular location directly to some other location without moving it one by one. Okay, so these are your branch instructions. Normally branch instructions are of two types. We have unconditional branch instructions and we have conditional branch instructions. Unconditional branch instructions means which do not follow any condition, whereas conditional branch instruction means they follow a particular instruction and then only they execute. Okay, so let's do the unconditional branch instructions. The first instruction in unconditional branch instruction is the call instruction. Okay, call means you can call a particular subroutine program and you can save the return address on the stack memory. Okay, so that means what? If you write a instruction like this, call 2050, that means wherever you are calling this particular instruction means directly the instruction which is given at the address 2050, you are calling that instruction directly to your program, and that means you are skipping all other parts of the main program. Okay, so that is why it saves the return address on the stack. That means when you want to skip this particular program, then you can go back to your normal program and your address is stored in the stack memory. Remember this thing. So next unconditional instruction is return instruction. Now what return instruction means? It returns from the subroutine to the main program. Now if you are writing written into a particular program, suppose initially you have written call 2050 and after calling 2050 to a particular point, you have written ret. So ret means it will go back to its original, its main program. Okay, so that is called return. Next comes jump. Now we all know what jump means. Jump means if you have given the instruction like this, jump 2050, that means for example if your program is at the address 2005, then instead of moving to 2006 2007 in a sequential manner, it will directly jump to the address 2050. So this is called jump instruction. Okay, that means it will skip all the lines, all the addresses which are between 2005 to 2050. Then comes loop. Now loop means, normally we know that loop, in case of if we are using a loop instruction, we normally use cx register. So it means that if the number of you can say if there is some number which is saved in the cx register, for example 4, so 4 times in that particular instruction the loop will move. Okay, that means you have to keep on rotating that particular instruction 4 times unless the value of cx becomes 0. Okay, remember this thing. So that loop will continue. That means that instruction will keep on rotating itself. For example, if you have written loop 2050, that means the instruction which is given, it loops through a sequence of instructions. That means those particular instructions will keep on moving until cx turns 0. So 4, then 3, then 2, then 1, and then 0. Then comes conditional branch instructions. As I told you that conditional means you have jump instructions, but only these jump instructions means the program will move to a particular address only if some kind of condition is fulfilled. Now let's see. First is JC. Now JC means jump if carry flag is 1. So that means first of all they will check the carry flag, the status of the carry flag. If it is 1, then it will jump to the particular instruction, particular address, that is 2050. Jump JNC means jump if not carry. Okay, that means if not carry flag, that means if carry flag is 0. Okay, that means if it is not high, JNC, jump if not carry. So that means if the carry flag is not high, and that means CF should be 0, then only your this will move to the address 2050. JZ, as the name suggests, J means jump and Z means zero flag. So you have to check this particular condition, that if ZF is equals to 1, then only it will jump to a particular address. Whatever address you can write, maybe it is written 2050, you can write 2008, anything. If you are at 2000, then you can directly move to 2008. Okay, just like this. So remember, then we have J and Z, that means jump if zero flag is not high, that means if ZF is 0. Clear? Then Jo shows that you have to jump if the overflow flag is high. Okay. Then JNO means jump if overflow flag is not high, that means if overflow flag is 0. Then we have JPE. JPE shows that jump if parity flag is high. Okay, remember this thing, JPE, that means it actually means that if parity is even. Okay, then we have JPO, that means jump if parity is odd. And in case of if the parity flag is odd, that means parity odd means parity flag will be 0. Okay, so both the conditions are fulfilled in this case. Then we have JS. Now JS shows that you have to jump only if the sign flag is high. That means if sign flag has the status of 1, then only you can jump. Jump if sign flag is not high. Okay, so JNS, jump if sign flag is not high, that means if SF is 0, the value, the status of SF should be 0 or low, you can say. Next instruction we have in case of unconditional instructions are JA oblique JNBE. Okay, that means now in this case you have to remember all these instructions because they are completely different from your common which I read right now. See, in this case, the condition is jump if carry flag is 0 and zero flag is 0. If both the flags are low, then only you can jump. Okay, so that is what JA or JNBE means. That means JA means jump if after, or jump if not before or equals to. Sorry, jump if above, and jump if not below or equals to. If these two instructions, if these two flags, if this condition fulfills, then only you can jump to a particular memory location. Okay, jump AE and J and B, jump if not below or jump if above and equals to. So in this case you have to jump only if CF is 0, remember this thing. Okay, and JE suggests that jump if equals to, that shows that jump if ZF is equals to 1. This is also same, you have to jump if equals to. So these are quite similar to ZF also, JZ and JC. JG, JNLE, it shows that jump if zero flag is also 0 and sign flag is equals to overflow flag. Okay, remember this thing, if these two conditions are not fulfilling, that you cannot jump to a particular memory location or particular address. Okay, so jump JG and JNLE. Then JGE. Okay, remember one more thing, JG means jump if greater than, and JNLE means jump if not less than or equals to. Similarly, JGE means jump if greater than or equals to, and JNL means jump if not less than or equals to. Sorry, JNL means only jump if not less. And in this case, you have to jump only if this condition fulfills. That means if sign flag is equals to overflow flag. Then comes JL and JNGE. Jump if less than, and jump if not greater than or equals to. So in this condition you have to make sure that jump if sign flag is not equals to auxiliary carry flag. Remember this thing, OF should not be equals to SF. So this is the condition when you can use jump if less than or jump if not greater than or equals to. Remember. Then JLE means jump if less than or equals to, and JNG means jump if not greater than. And or in this case, what should be the condition? ZF should be 1, whereas SF should not be equals to overflow flag. That means sign flag should not be equals to overflow flag. So this is the condition, remember. Okay, then comes JCXZ, jump if CX register, that means the counter register, the loop is completed. Okay, so you can only jump when the CX, that means counter register, is equals to 0, that means all the loops are complete. Okay, then we have loop instructions also, for example loop E and loop Z, and this indicates that you have to give a loop while ZF is equals to 1 and counter register is equals to 0. That means in this case the loop will keep on giving till CX turns 0, and also with the condition if 0 flag is 1, remember. Then comes loop NE and loop NZ, that means in this case you have to make sure 0 flag should not be equals to 1 and counter register should be 0. Just one thing is changing in all in these two. Okay, what is the change here? ZF is equals to 1, that means 0 flag is high, here 0 flag is low. Okay, so this completes your branch and control instructions. In the next lecture we will deal with the next topic. So till then, take care, bye bye.